Welcome to 126 class meeting. Thank you all for coming. Today we're going to be talking about Guitar Hero. So the agenda for today is I'm going to quickly debrief about LFSR, which we graded yesterday. I'll give you a little bit about what the outlook was from grading them. Then we'll talk a bit about Guitar Hero, overview what the assignment is, go into details on the hardest part of the assignment, which is ring buffer, and then go to the implementation details of Guitar String and how to go from Guitar Hero Lite to Guitar Hero. One important thing that I'm trying for the first time, at least for myself today, is I'd like to invite you to ask questions. I've never tried this before, so we'll see how it works. There's this website that you can go to called sli.do. And when you go to that website, you enter the code 5904. It's the last 4 digits of my social. I guess that wasn't a smart choice. But so if you post questions and upvote questions from other people on my phone, I'll monitor them. And I'll try as much as possible to answer them as I go. Of course, there's some questions I might miss, and there's some questions I might not want to answer today because of the amount of time that we have. But I would like to try this to engage with you better because I've noticed that it's hard to ask questions in a large amphitheater like this. Okay, so I'll post a reminder of this if you decide you want to join throughout the session. So first, a debrief on LFSR. So what I want to tell you is that we're trying to, I think our grading process is pretty good, but we're going to try to improve it. In particular, I'm going to try to develop the explanation. So we're looking much more into the stuff that you're doing in the assignments. So the grades for most assignments, which we graded yesterday and we will release tonight, was everybody got a 5, some people got 4.8, and then some people had a few big misunderstandings that resulted in some lower grades. What's interesting is that 1/4 of people picked the string representation and 3/4 of people used the int register. And of the people who used the string representation, some did really well. They used substring. They used really smart ways of combining all of these parts. But others have some predictable problems. So like, for instance, when they were rebuilding the seed, they were concatenating each bit of the string one by one. And if you've been to your performance precept, you'll see from that repeat exercise that you can't concatenate a whole bunch of strings like that because it gives rise to quadratic performance. Some more style comments from common deductions that we've had that I'd like to impress on you is a lot of students, so 1/4 about, used hard-coded values. So hard-coded values is when you pick a value like 8 that's important, that has some significance, but instead of having a constant like is here, you just repeat that number. It's not good and it's confusing because if somebody reads your code, they don't know if you pulled that number out of your hat or if it's something that has a significance. They don't know whether they can change it or not. So when you have a constant and you give it a name, you give an opportunity to document what that value is and explain how to change it or whether not to change it. So we will start deducting on this type of thing next week. The second thing that may be useful for people to know is that when you have an instance variable and that you're only going to assign to it once, you can use the final keyword. The final keyword, as I've demonstrated in the first bit, is useful because it helps Java protect you from changing that variable if you make a mistake or if you assign it by mistaking it for one of your local variables. So using final is a nice thing to do when you are using constants. Oh, and the last thing is we've noticed a lot of people had trouble converting from characters to integers. A lot of people used integer.parseString of a string plus the character or something more exotic. So the appropriate ways are to use character.getNumeric value or to subtract the character 0 from x, which will provide you something between 0 to 9. So please provide, you might notice, so I'm going to try to have really good explanations for this assignment, and I really would like your feedback on them. In particular, I'd like you to tell me whether the quality of the explanations are getting better, and also whether they're useful to your progress, whether they're useful for you to improve your coding ability. And so you'll notice that there's these thumbs up and thumbs down button. They do not rate the grader, they just rate that particular comment, that explanation. So finally, a last thing that I would like to talk about is about testing. So testing is something that we haven't really taught you how to do. And it's a very, very compelling and very rich topic that you'll get to see later on in the Coast Department if you decide to take more courses with us. But for right now, I'd like to tell you just two general rules. First, when you have a class, it's really good practice in your main, it's really good practice to call every method that you're defining at least once. Why? Because that way, if there's a really bad bug in any one of them, it's going to crash your program and you'll get noticed before you submit it. But whether your functions crash your program or not is a really low threshold of correctness, right? You would hope that they also produce the right results. So here's an example of how you could have done a more robust test. In the assignment, we told you this piece of code over here in that square produces that output, and it was provided to you below. And what was important was the sequence of values that are returned by generate 5. That sequence of values is 25, 4, 30, 27, and so on. So the way that you tested whether that piece of code was accurate is you ran it and you compared that output. But you could also have the computer do that for you. The way to do that is, one way to do that is here. So there's this method called assert that will create an error if ever what's in the assert parentheses is false. And if it's true, it won't do anything. So here, since I know the order in which the values are going to pop out from generate, I can simply compare them one by one. And if my implementation of LFSR is incorrect somehow, this is going to raise Java errors when it's being run. So assert is a really nice tool, the one that a lot of programmers use. If you don't feel comfortable, you can experiment with it in JShell. But if you don't feel comfortable with it, it's okay. You don't have to use assert. But the important thing here is that you test what your functions return and that you also have a hypothesis, a guess, as to what that value should be. Because if you just run your commands, you could say, you know what, whatever they produce is good enough. Whereas if you pick a result, you're already setting an expectation that something specific should happen. Okay? Let me just check for questions about this. So one question that I really, really like is, after an assignment has been turned in already, are we allowed to look at each other's code? I would like to compare my LFSR implementation to that of others. Whoever posted that question, absolutely, yes. Do compare each other's implementations. In fact, one of the things that we're working on is how to make it easier for all of us to share various implementations. Because one of the most important and exciting things about computer science is that not all paths lead to Rome. Many different paths lead to Rome is what I mean, sorry. So there are really many different ways, like essays, to do something. And it's really useful to compare how other people have done something. So absolutely, after an assignment has been posted, you can compare code with each other. You're relieved from the burden of having to keep everything private. So there's a question about substring and how to use it instead of concatenation for better performance again. So I'm not going to explain exactly how substring works in this assignment, but this is a good question, and if you post it on Ed, I will reply after this submission. The class meeting slides will be available after this presentation. So now let's go into Guitar Hero. What is Guitar Hero? So in Guitar Hero, it's an assignment that's related to physics and to music. And what we're doing inside of it is we're simulating the vibration of a string and the sound wave that that produces. So what you'll be able to do is create an actual digital instrument and deepen your understanding of classes in Java. So to just cite the context before we dive into the details, because I won't talk about the physics again, what really is happening, what you can think of in your mind, and I'm no physics expert, So whenever you pluck a string, it doesn't matter which direction you're plucking it or how hard. What matters is that the string is going to oscillate after it gets the impulsion, and that when it oscillates, it makes the noise. So in that sense, what we're doing with the ring buffer is we're creating the oscillation patterns, and at one point we're going to eject a lot of noise, and that will be the equivalent of plucking the string and see it then dampen to its zero excitement. So the overview is like this. You're going to be working with 3 different classes now. So it's a step upwards from LFSR, where you had LFSR and PhotoMagic. Here you're going to have 3 classes. First, ring buffer, which is going to be your first data structure that you're implementing. And it's going to be a queue type of data structure. Then each guitar string is going to use 1 ring buffer, and Guitar Hero uses 37 guitar strings. So the architecture of your program is going to look like this. Each guitar string is going to have a ring buffer, and there's going to be 37 of them tied to Guitar Hero. What you need to know, well, in this assignment, we're really trying to get you to practice with juggling more objects. So the practice that you're getting here is in using different objects and combining them with each other. What you're going to learn in this assignment is an introduction to data structures, and specifically to the Q abstract data type, which we'll be talking more about in the following weeks. You're going to learn how to implement a complex abstraction. So ring buffer is a circular buffer of sorts, but since we don't have circles in Java, you're going to have to use modulo, wraparound, and cursor variables to keep track of the contents of that buffer. And for the first time, you're going to be implementing a real-time event loop where you're going to be interacting with your program through the interface. So one important thing, starting with Guitar Hero, that we really recommend is that you can now partner with someone. You can partner with someone from your precept or from outside of your precept. The only requirement is that we ask that you review our partnering policy, because we have some rules, namely that both partners need to be involved in any type of work that takes place in the assignment. So we used to require that people be physically in the same room. We now are evolving with standards, and if you want a video conference and share your screen to talk about code, that's also fine, but both partners need to know every bit of the assignment. So it's not just good to save time and have somebody else to work with. This is actually how a lot of programmers in industry practice, because it's a lot easier to catch. Every programmer is going to make bugs. It's a lot easier to catch them when there's 2 of you. Oh, and the way to do this is in Tigerfly, you're going to need to create a group, including when you're only submitting the assignment yourself. So this, I couldn't find anybody to do the assignment with me, so it was alone. And you can see Lumbroso confirmed. Yeah. So reminder, you can ask live questions, and I'm going to take this moment to scan through them. No, you will not get points deducted if you do not use a cert. This is just a tip. Okay, thank you so much. Now we're going to talk about ring buffer. Ring buffer is an implementation of the Q abstract data type that we're going to talk about next week. You'll hear about this a lot more, but I'll just give you the headlights if you haven't seen it. A queue is simply a data structure that has these 2 operations, enqueue and dequeue, and that keeps objects or values or whatever in the order in which they've arrived. And it's called a queue by analogy to like a queue of people or a queue of items on a shopping cart line. What's important and specific is that typically queues can have any number of elements, but our ring buffer will have a fixed capacity. And that's important because typically queues are implemented with something that we'll see called linked lists that allows you to easily grow and shorten to any number of elements. But right now we don't know about linked lists, we only know about arrays, and arrays cannot be resized. So that's why ring buffer are going to have a fixed capacity. And the important thing is simply that enqueue adds an element to the ring buffer, and dequeue removes it in the order in which they've been inserted. We're going to talk about an example of ring buffer to just keep you in mind what is the difference between what the object is, the ring buffer, and how we implement it with like a linear array. So the ring buffer here is what the abstraction is. We imagine that there's a ring and that the cells are circular. But again, we don't have rings in Java, so we're going to implement it as an array, and we're going to be the ones that have to make sure that we wrap around it. So initially, what we have is this double array in the bottom. We have the capacity that is 6. It's the length of that array, and it never changes. The values are initially all 0, and we have 3 variables, first, last, and size, that are initially all set to 0. Okay? So by the way, again, you'll have these slides, so you'll be able to review this example offline if you need to. So that's the setup. This is how we are in the beginning, and now I'm going to do a sequence of operations, and we're going to see how it affects these variables. First, we start in the upper left, and we're going to go left to right and top to down. First, we go from the initial ring buffer that was empty, and we enqueue a new value, 0.4. So that new value is going to do, all the changes are the things that are in blue up there. So what's going to happen is that the first cell of the array, its value is going to be replaced from 0.0 to 0.4. And the position of last, which was 0 to signal that 0 was free to add a new element to it, is going to move to 1. And you can see what that does both in the circular and the array representation of our ring buffer. Okay, and so the last thing that changes is size was 0, and we now increment it to 1. Next, we enqueue another element, a 0.72, that adds the second value in the cell number 1, both in the circular and array representation. It moves last, it increments it by 1 spot, and it increments size again by 1. So again, same 3 operations, change the value in the array, increment last by 1, increment size by 1. Okay? So now we do that again with enqueue of 3. We modify a value from 0 to 0.3 in blue. We increment last by 1, and we increment size by 1, which is now 3. Okay, so now we understand how the enqueue operation works. So let's try to use the dequeue operation that removes a value and see how that changes the data structure. So here we do dequeue. What does it do? Well, it returns the value that first, the cell first was at up here. So first was in front of 0.4, and notice how rb.dequeue, there's an arrow that means that it returns 0.4. Okay, and what else changes? Well, first is incremented by 1, and it's now in cell position 1. And size is decremented by 1, so it's now 2. Notice, though, that the value 0.4, we forget about it, it's ghosted, it's now gray, but it hasn't been removed from the array. The only way that we know that we've spent it, that we've read it, is because first has shifted 1 position to the right. So first is the one that's indicating what the front of the ring buffer is, what the next value that we're going to dequeue is. And first is what we're controlling to say that we're done with 0.4. Okay? So then we enqueue 0.11, and again, nothing changes. We change the next value that last was in front of. We increment last by 1 and re-increment size by 1. And by now, you're getting tired of me explaining the obvious, but we'll do one last one, which is dequeue. Dequeue here returns 0.72, which is what was in cell 1, what first was in front of. First is incremented by 1, and size is decremented by 1 as well. Okay? One operation that I haven't talked about that's really important, it's the peak operation. The peak operation is important because it allows you to read what is in front of the ring buffer, but without removing it from the ring buffer. And we'll see later on why that's important. So the peak operation provides the same output as dequeue, but it does not change the ring buffer. So we were in the last position G, and now I'm going to show you the difference between doing peak and doing dequeue. Both of them are going to return the value 0.3, both of them. So RB peak returns 0.3, and RB dequeue returns 0.3. But in the case of RB peak, it changes nothing. None of the values change. There's nothing that's in blue. In the case of dequeue, as we've seen before, there are 2 things that change. first moves from here to here, indicating that we've spent 0.3, and size decreases by 1. Again, in all of these slides, capacity is 6 and has never changed. So now we come to the wraparound. I want to give you a little bit of an example of where the wraparound is involved. So eventually, if we continue adding values first and last, we'll have to wrap around the array. So the way to handle this is to use the modulo operator, which is %, and to combine it with the capacity variable. So I'll let you imagine what the details of that would look like. But here is an example to show you that it's really no big deal. So here we enqueue a last value 0.8. So last goes to the very last spot, which is 5. And so it means that the next step when we're enqueuing 0.27 means that last has to wrap around. And notice that the only thing that makes this legitimate is that last is still before first in the order of the ring buffer. What would be bad is if first and last were to meet at some point. That would indicate that your ring buffer is full. So one thing that we do not require, but that I used when I was doing this assignment on Sunday, and that I recommend that you do, is to try to find some useful string representation of the ring buffer that will help you debug what's going on when invariably something does go wrong. So here's the representation that I was able to pop out of my ring buffer. So I keep track of as much information as I can. You don't need to keep track of everything, but here I keep track of the values. I keep track of the cells that contain a 0. I display them as blank. I keep track of the indexes of the cells and the position of first and last. And that helps me visualize very well what happens inside of the ring buffer by printing it to the terminal and making sure that everything works correctly. Again, this is my recommendation, my tip. It's not necessary, and we will not deduct if you don't have this. So here, for instance, is what my main looks like. So I have a whole bunch of NQ operations. I have some DQ operations. I'm not using the advice that I gave you initially, so this is a case of do as I say, not as I do. And this is the output that I get with my string representation. So notice how this is the exact same example that we did with our circle diagrams, but here it's the computer, the program itself that shows me what's going on. There are a couple pitfalls that I like to warn you, and again, in warning you of pitfalls, what I've done is I've looked at past semesters and I've looked at what problems they had, and so invariably you're going to get different problems because you were paying attention to those but maybe not others, but that's okay. Again, an important thing that can confuse you when you first see this assignment is that capacity never changes. Capacity is just the size of the array that you initialized initially, and it never changes. You never resize that array. So the second thing that I would suggest is do not try to compute size. So especially if you're ambitious, especially if you're like me, at the very beginning when I first saw this assignment about 4 years ago, I was like, no, I don't need an instance variable. I can compute this on the fly with first and last. Complete catastrophe. Why? Because when first and last are in the right order, it's fine, but then when they stop getting swapped, it becomes a little bit chaotic, and keeping track of when they're swapped or not can become really difficult. Really, the tip that I tell you is do this the simple way. Have a size variable. Whenever you add an element, increase size by 1. Whenever you dequeue an element, decrease size by 1, and don't ask any more questions. That's the easiest way to do it. And then finally, remember that the array can be filled with ghost values. So in the example that I provided you, notice how I grade the values when we weren't interested in them, but they didn't go anywhere. They were still in the array until they were waiting to be overwritten the next cycle of the ring buffer. Okay? So now let me check for questions on this section, if you have any. Is working individually not recommended for this assignment? Oh, that's a very good question. So the partnering is not a question of, these assignments are very difficult now and it requires 2 times the same brain power. No, it's not about that. It's about, in the first few assignments, not everybody was familiar with programming. So if you were to pair up right away, there was always the risk that one partner would be like railroading the other and taking charge of everything because they were just more familiar. So for the first few assignments, we want everybody to work on their own. Now, it's not that the assignments are harder, but it's that partnering with somebody else is fun. It's a really nice practice. It's really nice to brainstorm and problem solve with somebody else. And we want to give you the opportunity to do it. But it's not a requirement. It's not something that is necessary because of the difficulty of the assignments. It's just an option and one that we extend to you and that you can do as you please. Oh, I'm sorry, I just realized I can dispel questions, which I guess would be useful next time to not go over all of them at once. After you DQ, don't you change the value to 0? So that's a good question. After you DQ, you don't change the value to 0. You could if you are OCD a little bit like I am, but it's really not necessary, and it's a waste of your time because that value will be overwritten. Are we required to use the modulo operator for implementing wraparound? My partner and I implemented differently. Do we need to redo it? No. Again, many paths lead to Rome. There's many ways of doing everything correctly. We're just giving guidance so that people are not lost. Because the point is to do programming. It's not to problem solve through the night. To submit the assignment individually, do we just create an empty group? Yes, absolutely. How do you throw a runtime error with a custom message? You do raise runtime exception, parentheses, and a message in between strings. That's a really good question. In ring buffers, capacity taken from the command line, how should we avoid hardcoding here? Very good question. So that's something we're going to talk about when we talk about Guitar Hero, and I'll come back to it. Okay, and then, yeah. So now let's talk about guitar string. So guitar string is a class that each guitar string has its own ring buffer. So again, the ring buffer, the guitar string is going to be using the ring buffer to simulate the karplus-strong algorithm. The ring buffer is going to act as that dampening mechanism that's going to make sure that there's an oscillation that happens. And what guitar string is going to be responsible for is plucking that virtual string by putting noise inside of that buffer and making it dampen. So the guitar string is going to produce the initial excitement, simulate the dampening of the string as it oscillates, and this is the important part related to the question that we just had. The capacity of the ring buffer will affect the harmonic of the sound wave. So depending on the size of the ring buffer, it's going to affect what frequency, what note that ring buffer is going to do. So the capacity of the ring buffer is going to be the note that you want that guitar string to have. So when we're going to see in the Guitar Hero client, you're going to create a lot of guitar strings, and you're going to want each to have a different frequency in hertz. And that is explained in the assignment on how to do that. One important thing that I want to mention is that when we introduce classes to you in Precept, what we tried to make sure is that you remembered to always initialize all instance variables in your constructors. And that's something so important that I had my students repeat it as a mantra. I'm not going to do it here, but it's something that's really important, and it's a very, very, very frequent problem. And it's a frequent problem that's even more frequent when you have two constructors, right? Because you have two constructors and you forget that it's either or. It's not both of them at the same time or one after the other. So you have to make sure to initialize all instance variables in both of the constructors. So you have to think, how do I initialize all of the variables, all of the instance variables in these two different scenarios? So the two different scenarios are the following. You're going to have guitar string double frequency. So that's a guitar string where you're going to create an empty ring buffer and include n zeros into it. And then you have guitar string that takes an array, and here it's going to create a ring buffer with the same capacity as the length of that array, and it's going to include all of the values in that array into the ring buffer before it begins. Okay? And so those two descriptions are in the assignment. And it's really important that you make sure to initialize all of your instance variables. The question that you're going to ask yourself, and it may be useful for you to think about it in the abstract before you start actually working on guitar string, is remember the goal of this assignment is how to piece together objects. So here the important question that we're asking you is, how are you going to be using ring buffer from within guitar string? So here are a couple questions to get you thinking about how to use the API, right? So in the first part, we created ring buffer, and now we're looking at its interface, its API, just the methods to understand how we're going to use it. In this part, we don't care how ring buffer works, we just care about how to use it. Ask yourself, what operations would you use to remove all of the items? How would you organize that? How are you going to fill the ring buffer with noise? So noise is random values between minus 0.5 and plus 0.5. Remember standard random and the uniform method, you might have to use that. Are you going to fill the ring buffer with zeros? How are you going to do that? Start thinking to yourselves how are you going to have a for loop that enqueues n numbers or so on, how you're going to use the is empty or is full functions up here to make sure that you're adding objects until it's full or removing them until it's empty, and so on and so on, and how you're going to combine that with while loops and for loops and so on. Now we get to the actual foliage of this guitar string, which is the tick method. The tick method is what's responsible for taking one step and further simulating the oscillation of the sound wave. So the way that it works is best explained by that diagram at the top, which is in the assignment description. So here it represents the ring buffer and the array representation, the one that I had in the bottom in my example, but it's that ring again. And these two values are what's at the front of this ring buffer. So 0.2 is what would be returned if I did DQ in my first call. Okay, so tick is going to simulate another time step of the sound wave we are calculating by doing the following. It's going to calculate the average of the front two elements. So 0.2 and 0.4, it computes the average of that. It multiplies that average by some decay factor for which you're going to define a constant. And that decay factor is equal to 0.996. So that's a value that has been empirically determined to make a nice sound. Okay, and then you're going to add the result as a new element to the back of the ring buffer, removing the first element. So actually, I should have swapped those two things. You first remove the element, and then you add it to the ring buffer, because otherwise the capacity would explode. And I'll fix that in my slides. Here, the important question is, notice how you are reading the two front values, but you're only removing the first one. So if you've been paying attention to the operations I've introduced, you should start thinking that you're going to be using maybe two slightly different operations for each of these values, right? And so what could we be using for that? Well, the operation that we could be using here is the peak operation. So for the first 0.2, we're going to DQ that value because we need to remove it anyway. But for 0.4, we just want to read it. We want to take a peek at it. So to take a peek at it, that's why we have that peek function that just tells you what's on the top of the ring buffer, but without actually removing that value or otherwise changing the ring buffer. So I have a question, which is, how is the precept on efficiency going to be implemented in this assignment? And I'm not quite sure I understand the question. So please follow up on Ed with that one. Will the performance efficiency of our programs be factored into our grade? Yes. Why? So slightly here, the reason why we will have to take into impact the efficiency is because it's not just to be pedantic. It's not just to say there was a really great solution, but you missed the mark. No, it's not for that. It's because now you're starting to develop systems that have to behave in real time, right? So right now, when you press, at the end of the assignment, when you press a key on your keyboard, you expect your program to be in real time as you're pressing the key, simulating that sound wave. And if you press 37 keys, you expect your keyboard to do a 37 key chord. So that was pretty unheard of just a couple decades ago. You know, the digital instruments, they always came from manufacturers with a caveat that says, can do one string at the same time, or two, or 8, or 16, or 32. It used to be a really big deal because it requires a lot of computation to have a lot of simultaneous chords. But the downshot for you is that if your ring buffer is inefficient, then your program is going to choke. It's not going to be able to calculate what the oscillations of 37 different strings are in parallel. It's going to stutter. It's going to make sounds that you don't expect. So that's why in this assignment, the efficiency is really, really important. So think about it in other terms. Efficiency is going to be required for any live system. So when you're flying on that Boeing 737 MAX, right, you want that system to be making decisions in real time, not after the fact. So that's the same thing here, except maybe the outcome of your ring buffer stuttering is less dire than the plane's. So we use raise instead of throw new runtime exception. Actually, I'm realizing maybe I said a mistake. It may be throw new runtime exception, and I may be confusing Python. My bad for that. Okay. Good question. Can you access the third element of the ring buffer without accessing the second one? What do you guys think? No, the answer is no. You can only access the top two elements. One with DQ, and that will change, and then the second one with peak. But if we want to look at more, we have to change the structure. We can't just peek at the third element. And that's really important because the art of data structure, and that's something you'll see in 226, is about making trade-offs. So here, all of our operations in Q, DQ, peak are really efficient, but it comes at the cost that we can't look at just any element in our data structure. We can only look at certains. So creating data structures, picking the right data structures, is knowing how to make the right trade-offs to get the performance in the places where it really matters to your programs and to your goals. How does ring buffer play into tick? That's something that should be clear from the description of the guitar string. So it explains how you initialize ring buffer and how at every cycle of the guitar string you're going to make a sample in tick. Okay, so I'm now going to move to the last slides of my, the last slide actually of my presentation. So once you're done implementing guitar string, you're going to now be testing it, trying to actually make music. So to scaffold sort of this step, because we realized that it's really hard to just go through this whole process without ever having something that you can try and test and be proud of, we've created this intermediate step called Guitar Hero Lite. So Guitar Hero Lite is this code that we've provided to you. And that code, everything is done in it. It's going to make a simplified Guitar Hero client where you can only do two strings, concert A and concert C. Only these two. And this will be an easy way for you to test that your guitar string works. So once you're done with ring buffer, once you're done with guitar string, if they work, you can run that program and try these two sounds off. So then the question is, how do you go from that to Guitar Hero? And so what I'm going to tell you here is just how you change this program, how you take this program as a skeleton, and how you expand it to have the functionality not just of just two strings, but of 37 strings. So with two strings, there are sufficiently few of them that we can create them individually. But when we have 37, or if we want to expand it to 64, it makes a lot more sense to have an array of guitar strings. So the first thing you're going to do here is you're going to change the declaration of each of the individual string into a guitar string array strings. Okay, and you're going to use a for loop to initialize each of the guitar strings at the right frequency. And there's a formula for that on the assignment, on how to pick the frequency. So next, inside of the event loop, so the event loop creates a keyboard visualization and then checks to see whether you've pressed the key. And then it does if statements to check if each key is the one corresponding to a string. So here, when you're going to move to your 37 key hero, do not use a 37-way if statement. That will be a deduction. It's a style mistake and it's an efficiency mistake. So do not do a 37-way if statement. Instead, what you are going to do is define a keyboard string that is provided to you in the checklist, and you're going to use the index of method that is going to provide the position of a character within that string. So that position is going to give you the index of your string in your array if you map your things correctly. Finally, after you've done that event loop, you're going to be responsible for updating the sample of the overall sound wave. So that's what you do here. So in this example, you just sum sample of string A and sample of string C. In the actual version, you're going to initialize a sample to 0 at every iteration, and then you're going to do a for loop that adds the sample of each guitar string to that main sample. And then you're going to play the sample and then update tick for each of the guitar strings, again, with a for loop that goes through each of the guitar strings of the array and calls tick with it. Okay, and so now 10:49, this is the end of the presentation. So I'm going to now review if there are any final questions, but I wanted to thank you for engaging with me, for your wonderful questions, and for just being a great audience. Thank you very much. I recorded this presentation, so you'll not only have the slides, but also my recording to follow up while you're doing the assignments. Good luck and enjoy.